Okay, it's live.
Is it on? Hello, online. This is Jackie. We're starting our second Regenerate the Earth class. And I've got some people present here who braved the coronavirus and the weather. They weren't here last week, so I'm going to give them a handout from last week as well as the handout from this week. And I'm going to want to review a little bit of what we did last week. So last week's regenerative design principle was to observe before you interact. So we talked about the history of the earth and the garden, and we asked a bunch of questions about what is going on there, like what resources are abundant, what resources are lacking, what are all the elements in the system, what is the system, what is the potential risks of interacting with the system. So we wanted to know, what could we do wrong? Right. And then we talked about presencing, which is the process of jetting up your mind and actually observing with all of your senses. And we did about 10-minute walk around and just touched and smelled and felt everything to kind of get a sense of what was going on. And then after that I gave a little tour and we did a little mulching. So that's what happened last week. And this week we're going to dive into soil science. Yay! So the regenerative design principle for this week is grow soil. But before we do that, I wanted to do a little check-in or just introduce ourselves. So I'm Jackie Stursel. And I've been doing permaculture stuff for about 20 years, a bunch of community organizing here in Norman, and then I was in Boulder for about 6 years. I just got back. So I'm kind of bringing what I got in Boulder back here, and I'm trying to be a business consultant for permaculture businesses, so I'm really meeting people to do that. So let's just introduce ourselves real quick, name, and then if you want to share something about yourself.
You want me?
Yes.
No.
That's my daughter, Dara. And
I'm Alana.
can you say her name?
Alana.
Dara's friend.
I'm Logan. I've been a cannabis farmer in the Pacific Northwest for about 5 years, and recently moved to Oklahoma and want to make our property and farm and everything as sustainable and biodynamic as we can. We've been planting and permaculture are definitely at the top of that list. So,
Thanks.
I'm Michelle. We just moved here. I'm originally from Oklahoma, though. I went to college here, my kids here. But I've been out in the Pacific Northwest farming out there for the past few years, and I'm excited to come back home and implement what I've learned here and be able to get medicine back home.
Cool.
Yeah.
Thanks.
I'm Joe. I was out west with these guys, and I'm originally from Illinois, but I just moved here a couple months ago and helped these guys start a farm.
Cool. Great. Awesome. Thank you. Cool. So second design principle, grow soil. That is the focus of regenerative agriculture. We're trying to build soil fertility by optimizing organic matter, mineral content, and soil life. For the most part, that's what we're focusing on, and then plant life and animal life should be able to take care of themselves as much as possible if we're taking care of the soil, right? So we're going to talk about some methods for doing this. Soil testing, minerals, inoculation, and building soil organic matter is what we're going to cover. So I'm getting a lot of this information from Dan Kittredge, who's freaking awesome. I definitely recommend you watch his YouTube series, High Bionutrient Crop Production. I just rewatched it before I put this together. I've also seen Elaine Ingham talk. I was in the Pacific Northwest recently and read some of her stuff online. And then Gabe Brown is a good example of somebody who's been implementing this stuff on a large scale. So those are some resources that are at the bottom. But yeah, so first of all, what's the difference between soil and dirt? Can anybody tell me?
Soil is living and has bioactivity. Dirt is pretty much inert and just depleted of all its minerals and nutrients.
It would just be sand, silt, and clay, right? And the organic matter makes it soil. So we want to get more organic matter. Plants need nutrition to give us nutrition, right? And in order for plants to get their maximum nutrition, they need a living ecosystem in the soil. You know, just like how our gut flora helps us digest our food, the flora in the soil helps the plants digest their food. So they need to have all of the fungus and the bacteria in order to break down the minerals, in order to make the phytonutrients that actually make the medicinal properties and help them fight off invaders and compete in their environment. So basically what we're doing by using chemical agriculture is we're using these chemical fertilizers. It's like putting somebody on an IV drip. You know, it's like you're not using their digestive system. You're just injecting it directly in them, and then they become dependent on that because they're not using their digestive system. So then they're really susceptible, especially to disease. So we want them to be eating the food from the soil. And the way that actually works is that plants, you know, they do their photosynthesis. They take CO2 and water and light and turn it into sugar. And healthy plants will inject the majority of that sugar into the soil through their roots to feed the microflora. And then the microflora converts that sugar with the minerals into other molecules that the plant sucks up and can use and convert into those phytonutrients. So yeah, the plant will first of all focus on creating sugar and then fats and proteins and enzymes. It's only once it has all of the minerals and all of the nutrients that it needs that it'll start making those phytochemicals, you know, like the terpenes and you know, the stuff that you guys want to see going on and that we want in our food to make it full, to have those pigments and all of the vitamins and the things that we want. Those are all secondary metabolites. And so another great thing about having all of the soil flora is that all plants should be able to fix their own nitrogen. You know, the only reason we think that beans and peas are the only ones that do that is because they actually need a certain microorganism to survive, but those microorganisms are everywhere, and then those would allow all plants to be able to fix their own nitrogen, get their own nitrogen from the fungi and the bacteria in the soil. I mean, nobody's fertilizing the forest. Right. So if we take care of that, we should not need to use any fertilizer. So, in order to make those conditions right, we need to make sure that we have all of the minerals present, all of the elements present that we need. So, we need to do some testing. First of all, there's the jar method, which we can do after we talk. We'll take a soil sample in a jar with some water and shake it up and let it settle, and we'll be able to see the amount of sand, salt, and clay. Approximately. You know, you can send things in for a test, but it's a pretty easy way to see approximately how much of those three things, sand, salt, clay, and organic matter, the four things, the organic matter would be floating at the top. One thing that can be a little bit difficult that I found is to tell the difference between sand and silt. And so I actually brought my microscope. It's over there. And I've done this before using my microscope to look at the particles to see and actually measure if they're silt size or sand size. Sand is great for aeration. You want some sand. But silt is that smaller particle size that those organisms are going to be able to break down into the minerals they need, including silica. So you want some of both, right? And so we want to do that, and then we want to do soil testing. The thing that Dan was talking about a lot in his videos was the difference between these kind of conventional lab tests and the Albrecht version of these tests. Those conventional lab tests, like the one here, you can go to the Cleveland County Cooperative Extension on Robinson and get a cheap soil test for $10, but it's just going to tell you soluble NPK and a pH. And it's really not very useful information. I mean, you're talking about how much salts are in the, or, you know, oh, you need to add more salt. Well, actually, these things are present. If you have the bacteria, it can break it down. Also, he was saying that pH should change all the time because these bacteria, they change the pH. They will will go from being a pH of 6 to a pH of 8 over the course of a day because they're changing the pH of the soil so that they can dissolve the minerals so that they can absorb them. So, you know, it's BS to oh, our soil is such and such pH. It just depends on how much microbial activity there is in the soil. It should take care of itself if you've got enough microorganisms. And then if you wanted to get more measurements from them, you do a saturated paste extraction to get all these minerals, but that still is only measuring the soluble salts of all of these other minerals. What you actually want would be the Albrecht test, and I actually brought, sorry, I forgot where I stuck those in my backpack, I suppose. Oh, they were on the back of the stack. So I actually brought some sample soil tests.
Oh, awesome.
So this is the saturated paste report, and this is the Albrecht. So you can see the difference here between the numbers that they give you for each of these different kinds of tests. And both of these are from Logan Labs, which Dan recommends as the lab to send in to for that test. So the more complicated one is the one that you want. And that's going to tell you how much minerals is actually in the soil, not just what's soluble.
Mom,
Yeah.
my phone's already on 20%.
Well, we'll get as far as we can. So we're running out of batteries. We're going to get as far
There's
as we can.
There's a port right there behind you, I think.
Well, then plug it in.
Well, I don't. I just
Okay.
need a second to do that.
Okay.
How about
So I helped you
She-Hulk?
guys out here, and I took what he said and I actually wrote it down. That Dan surveyed a bunch of students of William Albrecht, and he got somewhat sort of agree on how much you should have of all of these minerals, and, and I wrote them all down. But if you watch his videos, he not only says how much target level need, he also talks about how much maximum that you should apply in a year to not overdo it.
Here we go.
Technical difficulty.
It's not.
And through his website there, bionutrient.org is his website. You can get that test for $30, he said. Yeah.
There we go.
Yeah. So, do you want to sit here? Maybe you can watch do it from this side.
Well, actually, it looks like it will reach.
Okay.
It is my phone.
All right. And then he gave the difference between saying bioavailable and soluble, not the same thing. Bioavailable means it's small enough for microorganisms to eat. Right. Soluble means that don't necessarily want. Hi, you here for class? Yeah, go ahead and grab a handout there. And there's also handouts on the back of the stack that we're looking at right now. Wait, no, I've got them in my hand, so I can hand it to you. So just grab the one on the top along
Can you like scooch over here so I can lean on you? No, the other way, so I can lean on you so I can. Thank you.
There's a couple different ones we're looking at. Okay, we were just comparing. Oh, that's the wrong one. Two different kinds of soil tests. The simpler soil test is the saturated paste test. It just tells you how many soluble minerals there are in the soil, like in salt form, and then the other one tells you how much minerals are present in the soil at all. Which, if you have enough soil activity, life in your soil should be able to utilize that. So you don't just need to know how much is in salt. All right. So yeah, you can do this soil testing, and then another method is to use the microscope. So with a microscope, you can actually count like how many bacteria there are, see the ratio of bacteria to fungi and nematodes. Depending on what you're growing, you might want a higher ratio of bacteria or fungus. So your annual crops, a lot of them do like more bacteria in the soil, whereas your perennial crops tend to like more fungus in the soil. And then you'd also, I recommend that you check out Elaine Ingham's online courses. She has an online course on microscopy where she actually shows you how to do all this stuff. She was showing us some slides at the talk I saw, where you can really see the difference between like the beneficial and the harmful fungus by looking at the mycorrhizae. So I believe she said that the thick white mycorrhizae are like the mushrooms, and the ones that you want is the thin, darker ones that are the like, the bad fungus you find growing in your wall.
Right.
So you can actually look under a microscope and see the difference. Just tell if it's good fungus or not. And you can also, as I was saying, measure the size of the sand versus the salt particles to see what you've got. And then, if you can identify certain organisms, beneficial nematodes versus, which ones you're looking for, that's more advanced stuff. But hypothetically, you could do that. All right. So once you have your test and you know what's in your soil, then you can add some stuff. So there's the adding minerals, and as I said, Dan put together this list of kind of optimum amounts of all of these elements. A lot of people will hire somebody to measure all of these things and tell them how much to put on their soil. It's really not that hard. Once you get the measurements of the parts per million in the soil, you subtract, take the optimum, subtract what you've got, that's how much you need, and then you take that times 2, and that's how many pounds per acre you need to apply. So it's really not that hard. But then, you have these different elements like gypsum, but they're not 100% of one element. So you've got to then divide by the percentage of that element in whatever you're adding to see how much you need. And then he was talking about these various compounds: gypsum, potassium sulfate, magnesium sulfate, dolomite, rock phosphates, animal manure, wood ash, calcium carbonate from lime, flowable eggshells, blah, blah, blah. These are some that he sometimes uses. So those would all have different proportions. And then there's a maximum. So some of these, like, wood ash, you don't want to put too much on your soil at once. So in his video, he listed out a bunch of, like, how much maximum you could put on per year. Some of these things, it might take several years to build up enough in your soil. But one thing you can do that doesn't have a maximum is just getting rock dust, like from a quarry. When they make gravel, there's a bunch of rock dust left over, and you can get it basically for free. You just pay for the cost of getting it to your land. And a ton, he said, was 3/4 of an acre, or 3/4 of a cubic yard. Sorry, 3/4 of a cubic yard is a ton of this rock dust. So it seems like a ton is a lot, but it's not really all that much. You can put it on the back of a truck and just throw it out with shovels, right? And you can put pretty much as much of that on your land as you want. So if you have a good source, he said basalt. Has the broadest spectrum of minerals. Granite is second best. Sandstone, not so good. You're just putting sand on your property.
Yeah, that's what we have.
Yeah, we have a huge sandstone shelf.
Right. You don't need any more of that.
No.
No, but if you can find a quarry with basalt or granite, you could get some of that, and then anything that those are lacking, then you could use some of these other minerals, right? Another option is Korean natural food I've been getting into lately.
That's what we do.
Awesome.
Yeah.
Our partner.
Yeah, cool. So I've been getting. I've done it a little bit, and yeah, they make water-soluble calcium. And I've done this, taking eggshells and crushing them up and charring them, and then you soak that in brown rice vinegar for a while, and then you can dilute that in water, spray it. You can use a foliar feed or just spray the ground to add some calcium, and then calcium phosphate would be charred bones. They have a few others, but those are kind of the two that I've used and the two main ones they use. And then the other thing is sea salt. So sea salt has all of the minerals, everything on the periodic table in pretty quantities and in the right proportion that they should be. So he applies 75 pounds per acre every single year, and the cheapest way to get that here would be from the Kansas salt. But he gets it for $100 a ton. I think he said that. Hopefully I got that close right. But anyway. So yeah, because there's all across the Midwest, there's a 40-foot deep deposit of salt from when this was an ocean. So, and that's a really good kind of salt. All right, and then the next thing would be inoculating. So you can use compost or worm castings or Biochar starter and just disperse that over your property to inoculate with some microorganisms. In Korean natural farming, we make IMO, which is a 4-step process where we start with some rice and set it out, let it be colonized by what's in the air. Then we add that to some other grain and let it sit. I mean, I've done this process. It's a big, long process. You can look it up.
There's actually an easier way, Jadam. Have you heard about
Jadam? Oh, yeah. He's like the easy
Yeah, he's
version.
got the easy way.
Quick and easy.
Yeah.
Sure.
Yeah. You take a 5-gallon bucket and put 3 gallons of water in it, put a handful of dirt, a cup of seawater, and you hang a potato in it.
A
Boiled potato in it to feed, to add the sugar, and you just let it sit for about 3 days so it starts bubbling, and then you can dilute that and use it to inoculate.
Yeah.
It's much faster than the IMOs, which we're collecting those too.
It only took us, what was it, a day and a half or something? And
Depending on
the
the
last time
temperature.
there was all kinds of bioactivity, and we were able to dilute it enough to spray. We sprayed, so far we've sprayed 3 7 by 100 foot garden beds.
About
raised
60
beds.
gallons.
Cool.
What's it called?
It's called JMS, Jadam Microbial Solution, and you just take a 5-gallon bucket and you get 2 of the paint strainer bags. You put the handful of dirt in one and the potato in the other, and stick to the bag. You just hang it over into the water and add a cup of seawater and let it sit there for 3 days, and then you just take the dirt and the potato out and dilute it down about 1 to 20, 30.
Yeah. So the whole point of IMO is to get a really is to get a really dense concentration of a broad spectrum of microorganisms. So you're basically just making like super compost, and then you can dilute that and spray it. Spraying is a little bit easier than like dumping large amounts of compost over your property, especially if you're on a larger scale. Another one is lactic acid bacteria, which I have a bucket of over there. We'll go look at over there. Maybe, yeah, hopefully it's okay. But yeah, I have a bucket of milk over there. So you collect some bacteria. I used some rice wash water and set it out there for a few days, and then I added that to some expired skim milk from the earth here, and I got it sitting in a bucket over there with some cloth over it and something to keep the critters out. So we'll see how that's doing. But that would curdle, and basically you're making like farmer's cheese, you know, and then you scoop that cheese off, and then the liquid that's left is full of lactic acid bacteria. And if you've collected a lot from the atmosphere, then you've got a lot of different strains of different bacteria. And then to stabilize it, I mean, you could just use that directly. You can also use it for your own use to replenish your own lactic acid bacteria on your body, although, you know, be careful with that. But to use on your garden, you could either just spray it directly, or if you want to keep it around for a while to use a little bit at a time, you could stabilize it with sugar. So use brown sugar, kind of a natural, like turbinado kind of sugar. And you just put enough in there that with enough sugar, it takes away enough moisture that the bacteria will go dormant. So it kind of puts them to sleep. You have to add a lot of sugar when you have a liquid, though. Some of these other ferments, you don't have to use quite as much sugar. So the fermented plant juice, so you'd go out early in the morning and clip off the little new growth tips of your plants or your weeds and pack them into a jar with brown sugar, and then let it sit and that'll pull the moisture out of the plants and some of the nutrients out of the plants, and then some of the bacteria that's on the surface of the plants will go dormant, and then you can take that sugar and spray it, and that will kind of give that bacteria initial feed to get going and spread. So you're kind of harvesting bacteria from your plants, giving them the nutrients that they need to take off, and then spraying them. Does that make sense to you guys? Is that, am I saying this right?
Absolutely.
I know what I'm talking about. Yeah, sure I do. And I didn't put this link on here. I should have put it in the resources. Is the Korean natural farming people? Dang it, what's his name?
Chris Trump?
Chris Trump, and the one in Hawaii. Drake. I should have put Drake and Chris Trump on here. Anyway, you can look them up. Korean natural farming. You'll find them. Watch some of their videos as well. And then fermented fruit juice is basically doing the same thing with fruit. And fish is doing the same thing with fish. It's how you make fish sauce. It's really yummy.
We went to the coast last year and got 5-gallon buckets full of fish heads from the bait station in Crescent City, and took them home and we had them.
I got them from docks. They were just broken fish. Yeah.
Yeah. Fish heads, full fish, whatever. Pack them in sugar, let it sit there. It's great. It's wonderful. Fish amino acids, and that's really potent for nitrogen, as well as all sorts of bacteria.
It is nice that the sugar kind of, it doesn't allow the decomposition process to happen, so it's not like you have a bunch of buckets full of dead fish in
Yeah,
your
it's not
yard.
nasty.
Like, you can't smell it or anything. It just does its thing.
Yeah, I mean, Korean natural farming, in Korea, they make fish sauce, you know, I think that's pretty similar to just how they make fish sauce.
Mm-hmm.
And then we have oriental herbal nutrients. So you take angelica, cinnamon, licorice, garlic, and ginger, and it's a 1-to-1, except for angelica is twice as much angelica as all of these other things. You soak it in alcohol, right? And then you would dilute that and spray it, and basically that just kind of helps to tip the balance towards the beneficial bacteria. It kills off some of the baddies and helps protect the goodies. So that's inoculation. Does anybody else have any other ideas for inoculation? Maybe I missed something. How to inoculate your soil. Am I being thorough? Great.
Yes.
No, I think so, yeah. This is everything we need.
Thank you. Cool. All right. And then the last one is just building soil organic matter in general. And I think something that people don't pay enough attention to is making sure you don't lose your organic matter that's already there. So number one, don't till. There's no reason to till unless you've got like sagebrush and you're trying to remove it and you put in something completely different. You really don't need to till. You can just drill little holes, you know, you can let things compost in place. Keep your soil wet. When it dries out, all of your organic matter just evaporates up into the air. So we really want to keep it mulched. We want to keep it wet using key line contouring. So if you have if your land is on a slope, then you can kind of cut into your slope where those contour lines are exactly, and that'll help the water slow down as it's going downhill, and it'll sink into the soil and keep it moist for longer. Hugelculture is taking dead branches and logs and basically just burying them in a pile, so you get some fungal activity and absorbs a lot of water. Ponds, especially higher on the property, will keep water going in. Rain barrels, and then the tidal force, if you have enough aeration, then the tidal force will pull the water up and down and basically water your crops twice a day. You need enough aeration to get that to go. And then keeping soil covered at all times. Bare soil is a travesty. It's like Mother Earth being torn naked. It's horrible. So keep it covered. So we can compost and mulch, although that's pretty energy intensive. on a large scale, like with organic farming. I mean, is organic farming more sustainable if they're using fossil fuels to truck in a ton of compost every year? Not really. So, you know, a better way to do it would be to use animals, because they'll just put the compost there for you. Or to use cover crops. And, you know, you don't have to remove your old plants, just broadcast that seed, and when your old plants die, the new ones will come up. Then biochar, I love biochar. Has anybody here made biochar? Yes. I've done it in a barrel. It's fun. Yeah. She's giving me a nasty look. So biochar is basically homemade charcoal. You can use any carbonaceous material. It doesn't have to be wood. It could be corn cobs. You want to make sure it's dry, though. Let it dry out completely so that you can burn it until it's black and put it out before it turns to ash. If it is wet, it'll burn too slowly and the outside will turn to ash before the inside burns all the way through. Does that make sense? If it's nice and dry, it'll just turn to charcoal real quick and you can put it out either with water or by smothering. And that gives you this charcoal that you need to charge before you put it in your soil. So if you put it in your soil without charging it, it's going to suck everything out of your soil. You don't want that. So you want to charge it either by putting it in your compost pile or manure, or just put it in a bucket and pee in it. Either way, it will charge it with all of your nutrients, and then that'll be a slow release process. It'll slowly release that into your soil, and it also, those chunks, or even teeny tiny chunks of charcoal, its homes is like a little hotel for bacteria and fungus. And so, I mean, you can grow fungus on biochar, you know, so it'll just grow in through all those teeny tiny little holes, and you'll just have this awesome little hotel, and it'll protect them as well. So it's a great way to protect your microorganisms. In times of drought or whatnot, they'll have a nice little home they can hide in and come out when it's better. And you can just broadcast that. You don't have to till it in necessarily, because if you have earthworms, they'll do that for you. Earthworms can digest 36 tons of soil per year. One earthworm. I found that online. I don't know if it's true. It said it on some website. And yeah, you want lots and lots of worms, like over 100 per square yard would be awesome. When you go out at night, if you've got night crawlers, they should be just out on the lawn having an orgy. You know, you should be able to see them. You know, and every time you dig, you'll have to be careful to not kill them all. So yeah, they'll turn that soil. They'll turn all of whatever your biochar you put on the surface. They'll just till it in for you. Plus the dead plant material and all of that. So that's how you build organic matter. Ways to build organic matter? Did I forget?
Like sheet mulching.
Sheet mulching?
Yeah.
Yeah, I mentioned mulching. I mean, if you have an area, like some of our areas out here are grassy, then, you know, taking some cardboard and wood chips or whatever and just doing that initially. But, I mean, you shouldn't have to do that each time, each season. As I said, it's energy intensive. I mean, if you have just a little garden in front of your front door, you know, sure, mulch the crap out of it. But, you know, I mean, if your plants are healthy, they should outcompete things. So, I mean, the way I see it, weeding is potentially unnecessary if you're really taking care of your soil. Weeds like a really nasty, bacteria-rich, denuded soil. Most weeds, like your dandelions and your grass, like they just like it to not be very nutrient-rich, because they come into disturbed areas first, right? So if you've got really nutrient-rich soil, that's feeding your plants, feeding the weeds, and they should be able to outcompete them. And of course, you can always eat a lot of the weeds as well. Yeah. So weeding. Yeah, weeding, I mean, if anything, just kind of going through and kind of chopping stuff, you know, every once in a while and just let it compost in place, you know, just to give your plants a bit of an advantage. But yeah, you shouldn't have to worry about the weeds once you get things going. Hopefully. Okay, we talked about everything. Any questions? No? Cool. So now we can go out into the garden. I can give you guys a tour first, and then we can do some of these activities.
The phone is fine to be unplugged
Okay.
now.
All right, let's go out here.
Yeah, sure. There's no one even watching.
I brought a glass jar, but it's the only one I have that was that size.
Oh, you can see through it very well. Well, I have one. It's not quite a quart over here.